But yeah, let's talk about all things cloud security. It's a slide I like to whack up here just to start things off of why are we talking about cloud security. I think every organization I work with is trying to find a balance internally of how are they going to pivot to the cloud, either because they want to digitally modernize or because the board has told them they have to. And then how are they going to use their existing people, processes, and technology to keep themselves safe and balance that drive of innovation, balanced against an external cloud threat landscape. Why are there cloud threats? I think it's quite obvious why there's cloud threats, but just the mandatory slide about numbers. Gartner thinks that in a couple of years' time, 19 out of 20 workloads, they'll go straight to the cloud. There's also a really large pivot to cloud object storage. Wasabi, which is a great company name, thinks that 93% of organizations are going to be increasing their cloud object storage this year. If the goal for a threat actor is to get access for encryption purposes, for threat purposes, for IP theft purposes, whatever that might be, there's a growing target here because of this trend. So what does the cloud threat landscape look like? I'm going to go into a little bit of detail. Please know that this isn't me, trying to paint a doom and gloom. This is a challenge that is absolutely surmountable. Not because I'm a tech vendor and I want to say that my company's the only one, with lots of people in this room. And if we focus on the right people, processes, and technology, we can solve all of this stuff. But I do think we should have open and clear eyes about the nature of the threats that are prevalent. And so in terms of trends, unfortunately, we're seeing an increased number of incidents, breaches, and cloud security events. Depends on who you like to get your numbers from. Some people say that there's an increase 12% year on year. Some people say 33% year on year. Thales did a great study of their own customer base of who had a cloud incident. Everyone agrees that the amount of incidents is going up. The nature of the sophistication in these attacks is also going up, which is something I find super interesting. So if we were to look at something like MITRE ATT&CK, tactics and techniques, which is going to map hey, how are people building these campaigns, just in the tactics and techniques that focus on cloud IaaS, it's gone from 50 to 54 to 61 in 3 years' time. And that's all based not on POCs, but what's literally been seen in the wild. So there's an expansion of tradecraft, quite literally, as well as there's a lowered barrier to entry. There's a lot of open source tooling. I'm going to walk through some of that open source tooling in just a second. Obviously, there's a ton of bot-operated stuff. I saw this really interesting PyPy typo squatting campaign of 500 malicious packages, each with their own creator. That's likely bot-operated. The Lemon Duck botnet, I think, is a really interesting use case. So Lemon Duck finds a misconfigured Docker API, spins up a container. It does it through ASP, Bash. It does a few things, but actually turns off Alibaba Cloud Service Monitoring. I think AWS will forgive me for mentoring another cloud provider in the use case of it led to some bad things happening here, and they were able to actually disable competing cloud miners and start Monero crypto mining. Start to finish, that's 15 seconds. All of it automated. And obviously we're seeing things like Worm GPT, Fraud GPT. So what do these attacks look like? It's interesting. Obviously, if you're connected to the internet, you're going to be pinged, you're going to be hit up. That's just the nature of, threats, right? It used to be that people wouldn't realize they were targeting a cloud environment. They'd be like, hey, there's an OS or an application level vulnerability, I'm going to target it. And then they'd be like, oh, I'm in a container. Now people are specifically targeting these environments. And the finding of OS and application level vulnerabilities and the exploitation of them is actually automated. Now we see fileless attacks on the rise. Aqua Security, love those guys. They say it's 14x. We're seeing wipers and ransomwares with Linux variants. So for example, AcidPour, which is a part of the Russia-Ukraine conflict, that's written in Go so that it can target Linux environments. Ransomware, Icefire, AlpV's ransomware that Black Cat uses, that one's written in Rust so that it can target Linux. We're seeing a larger focus on Linux ransomware. Container-specific attacks, of course, like mounting from file systems, cryptojacking. We talked about that crypto mining, so you get that one. And then the last one, something that I think we'll see more of is AI, Gen AI-driven malware polymorphism. Malware polymorphism, it sounds scary. It's been around for 20 years. It's not a thing that we need to worry about. That being said, there was an interesting POC called Black Mamba, which defeated about 95% of cloud security tools by rewriting at the time of execution, which I thought was pretty cool. Pipeline threats, obviously we're seeing a lot of supply chain threats in the wild. I'm seeing a lot of threat actors that are translating to non-standard languages because they know that if your SAS, DAST, SCA stuff is not looking at a non-standard language, then it's going to get through the gaps. So they're hiding in compilation as well. I'm seeing repos targeted for harvesting, a lot of CI/CD pipeline abuse, account takeover. So this has happened a couple times. There was an interesting one, CTX. It was a package that was downloaded 2,500 to 3,500 times a day. The account owner on GitHub had been missing since like 2013, 2014. A Turkish university student was able to spoof the email address, take over the account, and he made a simple change. If you're still using this package, send me your AWS creds. Not great. So anyone pulling latest from the package or anyone that was freshly downloading was hit by that. They think it's about 250,000 organizations were hit with that one. And finally, I'm seeing threat actors target developers themselves. There's quite a large cryptocurrency organization. They had 11 of their developers get LinkedIn recruitment messages from their largest competitor offering them a pay rise. It was a fake job interview. Part of it was, hey, can you please build this hello world, but can you include some artifacts from our repo? Dumped his Chrome creds. He was using a password manager, so he got onto GitHub, got onto Docker Hub. This developer had no access to a production environment. But because they're able to map the business logic, they're able to do internal image implant, they're able to ensure that, one, they knew when the environment was going live, because it was a legacy application, it was sporadically live, that they could run some reverse shells. They tested with one Ethereum, that worked, second transaction is 42 million USD. That's Lazarus, by the way. That's a North Korean group who have been using that interview strategy for a long time now. Used to be that they would just do job descriptions with macros in them. This is now a little bit more advanced. And then, of course, there's cloud misconfigurations. Like, I'm not going to chat about this too much. I think we all know, let's please not have S3 open and unencrypted in public. Like, that's not what we want for ourselves. What I'm seeing is a lot of threat actors are modifying and disabling cloud services, which introduces a new challenge. If I'm going to assess my cloud posture, I now need to differentiate between what comes from my templates, what comes from my developers, and what's actually being changed externally. What's a malicious misconfiguration that doesn't actually come from me? And the reality is as well that I've painted this pretty picture of like 3 neat verticals. The reality is a lot of cloud attacks will mix tactics and techniques across those pillars. Looking at this another way, if I was to look at something like MITRE tactics and techniques, initial access, execution, persistence, privilege escalation, defense evasion, credential access, discovery, lateral movement, collection, exfil, and impact. We're seeing all of these for cloud compute. We're seeing these for cloud identity, these for cloud services. And they're mixing and matching within these complex campaigns. SentinelOne has... I should have introduced myself, by the way. Hi, I'm Chris. I come from SentinelOne. We've got some great blogs on these two specifically. Open source tooling. I talked about a lowered barrier to entry. Let's have a look at what this does. So first, you've got to use a security aggregation service like SecurityIX, Leak Trails, to find the environments. And we want to target web environments, so like Joomla, WordPress, PHP type places. All this is automated. All this is open source. Dumps the config files, extracts what it needs, imports Bodo 3 and uses the AWS access key, creates a new login profile, deletes the original, and it bumps up admin access privileges. All this is automated. Now you might say, Chris, this is all well and good. I don't believe you. Let's have a look at a real-world example. So I'm going to chat about Roasted Octopus. Roasted Octopus, this isn't some scary group of Russians or Chinese espionage. These are teenagers that are American. These are teenagers that are English. These are teenagers that are Australian. Now, in this instance, they're working with a Russian ransomware as a service operator, Black Cat, because usually what you do is you get in and then Black Cat locks it for you and then they help you get the money. They love phishing. These are the same guys that did MGM, by the way. So you might have, if you've heard about the MGM hack, it's these guys. Roast Octopus are also known as UNC, N344, Muddled Libra, Scattered Spider, Choose Your Poison. It's these guys. They love smishing. SSO, so they jump from Azure AD into AWS IAM through the SSO. Then they use Systems Manager Inventory to start doing their discovery. They created a brand new EC2 instance in a security group to allow for a backdoor. They created a new user and they added MFA. You often don't see MFA being added by threat actors because it's often people are looking for where isn't there MFA. They bumped up admin access rights. They bounced between those two profiles. They successfully disabled guard duty. They unsuccessfully tried to delete CloudTrail. And then they deployed that ransomware that I was talking about, the Rust one, into S3, back into the on-prem environment as well. And so there's a few takeaways here, right? Like, one, that leveraging, modifying, disabling cloud services. I like to call this almost like cloud lol bins, if you're interested in threat hunting. That's me being very nerdy. There's a pivot to ransomware, to storage, to on-prem, and there's confidence in defense evasion. Endpoint security is pretty damn good. That's not only because of SentinelOne, that's because of a lot of other organizations. Cloud security is still a challenge for a lot of organizations, and threat actors know that they can get away with successful campaigns in this environment. Why cloud security is broken, I think, not because of any tooling, but because of often there's a misalignment for what do we need tooling to achieve. I know a lot of organizations that nail build clean, operate clean, detect, but then they can't chain everything together. And a lot of people will have a million and one tools, right? That's very common. I don't think the problem is too many screens, because people can live with too many screens. It's how do I correlate and have all this contextualized. If there's something happening in my containers, I need to know what's happening with the privileges and roles and permissions attached, what's happening with any storage attached, what's happening in real time, what's the health of the Kubernetes admission, what's the health of the container image. I want to see an SBOM. Like there's just a few different things in play that I need to look at. And often a lot of security tooling is incredibly noisy, like cloud security posture management, noisy. Often without prioritization, and often not acting at machine speed. I see a lot of security that's visibility, which is great, but I'd rather something was stopped as it happened. What I'm seeing this cause is a lot of friction between cloud teams, incident response teams, vulnerability management teams, AppSec teams, DevSecOps. I'm seeing a lot of teams that aren't enjoying working together. Security teams are sending DevOps 10 pages of CVEs. They say, I don't know what package, what layer, what's public, is it exploitable? And they're not talking to each other. And so it's just really poor operational efficiencies and broken racy matrices. And I think things like I was going to say XZ, but I should say XZ because I'm in America. But and Log4j, like when these things happen, it's like, hey, where does this thing exist? What's happening because of this? Where else in my pipeline does it exist? And that kind of smooth pivot to let's find something, let's see the activity, let's correlate, but then now let's clean up an image. Whether it's an AMI or a container image, let's clean up a template. That's difficult. Now, SentinelOne, obviously I'm here to say that we're here to save the day. It's all people processes alongside technology. But we do have a really strong AI-powered CNAP on offer. That's got two main halves. Agent-based security that's going to take action as you need it to at machine speed. If the threat landscape's machine speed, protection needs to be at machine speed. And then agentless security that's going to help you radically reduce your cloud attack surface. Let's make sure that things don't happen, but let's acknowledge that things will happen because that's the nature, like bad stuff happens, so let's be ready with machine speed. Agentless and agent-based. And then there's cloud data security as well, but that's not as interesting. It's good, but not as interesting for me. So I want to talk about it. That's the AI-powered CNAP vision. Now let's look at cloud-native security, which is the agentless stuff. A lot of acronyms that you see from everywhere else. CSPM, KSPM, vulnerability scanning, secret scanning, container security, like everything that you'd expect from an agentless CNAP. Now what we do is We'll understand what's public, what's misconfigured, and what's connected to each other. That's an attack path. Attack paths are theoretical. We take it a step further with the offensive security engine. What we'll do is we'll actually dynamically generate an attack, defanged, and run that on the environment. So in this case, we've got a meta-based vulnerability. This is what it looks like. If I was to scroll right, you can see the curl, you can see the get. If I was to scroll right, you'd see it then queries and pings IMDS version 2. So no misconfig there, you've done the right thing, you're not on V1, you're on V2. But because of this meta-based vulnerability, it's allowing for server-side request forgery, and we'll take the screenshot. In this case, anyone running this from a non-blacklisted IP is going to get the access key token, keys to the kingdom. I like to call this the so what artifact. I don't want to talk to people about criticality, about 8.1, about CVE, whatever. I'm going to send them the screenshot and say, hey, this is what's possible. That's how we wake people up when we need to wake people up and say, like, hey, I'm not going to talk to you about 10 theoretical things. I'm going to talk to you about one really serious thing that I want us to fix before lunch. We call it verified exploit paths because we're going above an attack path and we're verifying it. We're validating it. Verified exploit paths. Here's a few things that we found. Grafana with default credentials. PHP MyAdmin. Swagger UI. It's stunning. We ran this for ourselves. We found some things that we weren't particularly happy with. That's just the agentless half. Then there's the agent-based half. Agent-based security is pretty simple, pretty standard. Hyper-performance, low impact, eBPF, so it's going to sit in that user mode, so you don't have to worry about any kernel panic. No issues there. You can bump to the latest. You're all good. And it's going to take actions as you need them to. It's got machine learning that's supervised and unsupervised, so it's got a mix of stuff it does at pre-execution and a mix of stuff it does at execution. But the important thing here is when something happens, at machine speed, stop it. AI-powered threats. Blocking. That's us in a nutshell. All of this is available if you want to check it out. I think it's awesome to check out the Cloud Native Security because we'll actually show you all of the exploitable things we find. So that might be cheaper than organizing a pen test or doing the work yourselves. Just come chat to us and we'll hook you guys up. Of course, it's agentless, so it's 5 minutes to set up to onboard those accounts. Fairly seamless. Same thing with the agent-based stuff. It's usually let's bake it into a template, let's push it out, let's be DevOps friendly about the way we get this thing out. But it's here to be used and abused in earnest. And that's me. Thank you very much for your time. We've actually got a minute 45. I've been booking through it. Thank you, guys.